And now going to part B. Part B says find the nature of the turning point of the curve. The curve is given by y equals to 3x squared plus 12x. Now, for us to find the nature of the turning points, we need to first find what the turning points are. So let us get the turning point. Now, for us to get the turning points, we need the gradient function of the curve. That means we differentiate the curve. So dy dx becomes 6x plus 12. This is the gradient function of the curve. But we are looking at the turning point. What do we know at the turning point? At the turning point, turning points, which is at any turning point, we know that dy dx is 0. Okay? The gradient of the curve at the turning point is always 0. That means we can substitute for dy dx as 0 so that we get the points. Therefore, what does it mean here? It means 0 equals to 6x plus 12. Then we find x. X in this case, we make x the subject of the formula. I'm getting x as negative 2, by the way. Because if you take 12 that side, it becomes negative. Negative 12 divided by 6 is negative 2. So, this is the value of x at the turning point. Okay? At the turning point, we have the value of x as x equals to negative 2. That is at the turning point. Now, what is the corresponding value of y at the turning point? Because remember, a turning point is a coordinate point. So if x equals to negative 2 at the turning point, what is the value of y? You come and substitute for it in the function of the curve. So y becomes 3, x is negative 12, x is negative 2 squared plus 12 times negative 2. Seems like it is 0. Negative 2 squared times 3 plus 12 times negative 2. It is 0. Okay? It is 0. So, when x is negative 2 at the turning point, y is 0. Therefore, the point in this case, the turning point is negative 2 and 0. Now, we have a turning point. Here we have only one single point. We have one turning point on this curve. What does it mean? It means that we now need to identify, is this point the minimum point, maximum point, or is it a point of inflection? And for us to do that, we said we use the method of getting the second derivative. That is, we find d squared y x squared. What does it mean there? It means we come back and differentiate the gradient function of the curve, or simply we differentiate the curve 2 times. So we have differentiated it here already for the first time, and we had dy dx as 6x plus 12. That was the first derivative of the curve. Now let us get the second derivative. So on differentiating this one again, we shall have d squared y dx squared equals to, if we differentiate 6x, it gives us 6. And if we differentiate 12, it gives us 0. So the second derivative is 6. Now, after getting the second derivative, then we come and test. Okay? We come and test. We use this point to test. We use this point to test whether it is negative 2 and 0. Remember, this is x, this is y. So, we shall substitute for x in the second derivative. But what do you notice? We notice that here the second derivative is independent of x or even y. It is independent of x. That means it doesn't matter what the value of x is. It will always be 6. Therefore, d squared y dx squared equals to, here we don't have anywhere to substitute for x. So, they will still remain as 6. Okay? Now, the second derivative is 6. Positive 6. What did we say? Positive 6 is more than 0. Okay? It's more than 0. And we said that if the second derivative d squared x, d squared y, dx squared is more than 0. Okay? If the second derivative is more than 0, we say it is a minimum. It is a minimum turning point. Turning point. Okay? If the second derivative is more than 0, we say it is a minimum turning point. Don't think it is a maximum turning point just because the value is above 0. No. If the value is above 0, it means it is a minimum turning point. Therefore, we have investigated clearly and we have found out that the nature of this turning point is that it is a minimum turning point. So the point negative 2, 0 is a minimum turning point. So this is the point and this is the measure of the point, and that clearly gives us the solution to part B.